Hey everybody, we've gone over how to use TensorFlow on a basic level. We've shown how to construct and do some operation on tensors. The best part about TensorFlow, though, is using the graph representation. This lets us learn and optimize variables in the graph. I'm going to start with an example of a menu application. And on top of this menu application, we're going to build a recommender. And I'm going to do this as a worked example, but it should represent a realistic scenario of having an existing application and wanting to add some learning capabilities on top of that application. For this video, we're only going to go over the example application, some background on recommenders, and what our goal is specifically. Then we're going to be designing a ZIO library for our simple recommender. We're not going to touch really much on TensorFlow. The next video will go into implementing the recommender with TensorFlow. If you're interested to know what that will look like, go ahead and check the links below, and there's a GitHub repo. The example application we'll be going over is a menu for an ice cream store, and the menu presents various ice cream flavors and asks the user to pick an ice cream flavor. We can see here the source code for it, but let's go ahead and run this example. And we can see here our menu asking us to pick an ice cream flavor, and we'll enter our ice cream flavor. We can see that we entered caramel, and it reports back the user selected caramel. And our console application here prints out the flavors, asks for a flavor, and just echoes back the flavor selected. We're going to start with this and add a recommender to it. Before we dig into recommenders, let's talk about kind of the goal from a customer perspective of what we're looking at. We have this menu here where they're able to select a flavor. Perhaps we have repeat visitors, or there's a most popular flavor, or such like that. And we really want to be able to tell people, hey, you probably want this flavor. In terms of a console user interface, it's typically done by using square brackets and placing some recommendation or default in there, such that when the user presses enter, it selects the default. And the first thing I'm going to do is actually just prototype this out in our little example application here. And we can see here selected flavor. We have our choice. Well, we want to somehow get our recommended flavor. And then in our prompt here, probably want to print out exactly like what we were talking about. Recommended flavor, like so. Do the little square brackets, just like I said. And then, in this case, we'll just start with this. And we can see already, I'm just running this on every change. We can kind of see the prototype here. Somebody presses enter. It says nothing's been selected. Of course, we want that to select the recommended. And that's if selected flavor empty. We're going to go with the recommended, else selected flavor. And we'll have it say actual. Let's yes. There we go. And again, pick an ice cream flavor, chocolate vanilla, blah blah, choice to do. And we see if we enter just to do. As we get back, but we can still enter a specific flavor and get that. Okay. So we've prototyped our interaction here and what it's going to look like to a user. I haven't done anything with TensorFlow yet, haven't implemented any services, but I've prototyped this, and this still is pretty valuable for validating this idea of even putting a recommendation for our menu here. You can imagine if this is a user interface for a web application or such, we could provide this as a beta or staging release to our UI designer or product manager for them to validate the idea before we invest in developing our recommender. What is a recommender? Let's go to the Wikipedia page and read it through. A recommender system is a subclass of information filtering system that seeks to predict the rating or preference a user would give to an item. And that's pretty much what we're trying to do here. We are specifically taking these items and trying to determine what is the most preferred item there. So if we were to infer the ranking or preference of each one of these items, there would be some order there, and we are picking pretty much the top preference present as our recommended item. We specifically are going to be working on a collaborative filtering recommended system. Collaborative filtering is a method of making automatic predictions filtering about the interests of a user by collecting preferences or taste information from many users collaborating. And that's the idea we're going to run through here. We're going to imagine that we have our population of users continually using this menu interface and selecting their actual preferences. And from that history of actual preferences for many users, we're going to infer what we think the prediction is going to be for any given user. This is taking a population statistic, which is the preferences for all our population of users, and trying to infer the recommendation for a given individual. Going from population statistic to sample statistic is ripe for ecological fallacies. In our case, we're talking ice cream flavors, so that's okay. But you really need to be careful when doing such a thing. Otherwise, really horrible things can happen. And while we're talking about really horrible things that can happen, I want to note that I've already biased the recommendation system. You'll note that our option of choices are not disparate. They're not all different. In fact, two choices are karma. Yeah, they're written differently, but they're pretty much the same choice. And that's my bias, that caramel is the best flavor, being encoded into our premise here already. I've done this on purpose just to demonstrate how easy it is. Okay, we have our idea of building a recommender, a type of recommender we're going to build, and we have our application that we want to add a recommender to. So let's proceed with building the interface that our application is going to use to interact with the recommender and add that to our application. We're not going to implement this interface with anything, but from our application's perspective, the implementation is separate from just how it interfaces with the recommender. I'm going to make a few design choices right off the bat. First, I'm going to say that the recommender used for the ice cream menu is defined by the choices. I'm not going to be using a case class here because a case class means that two recommenders are the same if those choices are the same. That is not going to be the case for this application. Imagine we have two different locations, effectively two different populations. Even though the choices may be same, the recommendations are going to be different. We're not going to define anything about that class at this time, just to state that there's a recommender defined by these choices. And that's all we have to write for that. In terms of the application, we're going to pretend the recommender is a service, and a service that's in the environment. We don't have to always treat the recommender in this way. We're going to make it a managed value so we can allocate multiples of it and use them interleave just fine. But for our application, we're going to pretend that there is a service in our environment that represents the recommender for this application. And we're going to just prototype what those interfaces look like. These are the two methods we're going to be using from our application. These are methods within the recommender object, and currently they operate in any environment, and our error type is throwable. We have one method called recommend that returns a string that is the recommendation, and we have another one that's called update, which updates our knowledge of the recommendations according to what a user actually selected. And this is where we're going to update our model for any new information. These we're not going to implement with anything thus far, but we can already apply them to our example application to get an idea of how they work. Recommended being produced by the recommend method of our recommender service in the environment. And then we have the selected flavor and the actual flavor that is selected. And in particular, if nothing is selected, we just go with the recommended. But if something is selected, then we want to update our recommended with the actual thing that the user selected. We see that failed right off the bat because, of course, we haven't actually implemented anything. But we can have our API design here available for review to see if users, in particular the developers, understand and agree with having a recommender as part of the environment being the primary way we use this. As standard with ZIO, these are just helper methods that dispatch to using the recommender in the environment. And of course, if you don't have the recommender in the environment, such as a variable containing that recommender reference directly, you could just use that directly. Let's proceed with implementing these helper methods. First things first, we're going to say that, well, this does actually require some type of environment. And that's going to be an environment containing the service or the recommender service. And these are going to access that service from the environment. And just dispatch directly to that implementation. This won't compile yet because, of course, we haven't actually defined this service type. Let's go ahead and do that. And this service is going to match these environment helper methods. We might, for some interfaces, have slightly different terms for the environment helper methods and the ones in the service to better match our domain language. In this case, they are the same. This won't compile quite yet because our program down here, we're using these methods that require the recommender service in the environment. Of course, we're not providing it. And that's what it's stating here. It found a program that required an environment and the environment was not available. So go ahead and provide an environment for this. Now, what should we add for this? I want to provide it as a layer because we're using it in the environment. I want it to be allocated as a managed value so we can take advantage of the deallocation aspects of ZIO to manage the deallocation of our TensorFlow resources, which is going to be really nice. And of course, zmanaged lets us, or a managed value lets us have multiple managed values in case we want to use interacting with multiple recommenders. But what should we put in here? One might be to have, a package of providers and say have a TensorFlow provider. And then have a method or class in here that constructs a TensorFlow provider for this layer. We're going to call this fresh in our case. That code would look something like this. And that does indeed compile and start to run. Of course, it ends with us having no implementation for this fresh method. However, as written, there's some issues here. Our application, it's unlikely we're directly concerned that this service is provided by TensorFlow. From an application developer's perspective, really just the recommender service. The fact that it's implemented by TensorFlow may come into question, but it's usually just a secondary aspect. But our interface that we've provided them requires them to directly reference how this is implemented. And without additional requirements, this is rather odd, because if you were ignorant of, let's say, recommenders, but you saw this library and it's like, oh, cool, I can integrate a recommender into my application, and you just saw providers, oh, I need to look for a provider there, and the only option is TensorFlow, and let's say another one, imagine there's another provider, just to make this clear, called, again, right, and you just saw those two terms. but you're ignorant of what TensorFlow is, or you're ignorant of what Huygen is, you wouldn't really have much to go on to pick an implementation. And that's kind of outside of your scope of your concerns as an application developer. You just want a recommender. But our interface that we've provided here has required them to have knowledge of what type of implementation they want in order to use something with a generic interface. Rather odd. Maybe they end up with a requirement like that, but it's nice from a usability perspective to not require that knowledge a priori. Fortunately, we already have a factory that we can build quite easily. And I'm using the recommender class as the factory. And theirs has a design choice as well. The recommender we're stating here is dependent on the list of choices. And you can see here that's exactly how we've written it. That means that this fresh recommender service instant depends on this list of choices. And this is an immutable list of choices. That design aspect means that if we were to have a different list of choices, let's say we add lemon to our list of flavors, then this recommender service that we have is no longer applicable. And that makes sense from a conceptual level, because imagine that you only have our original list of flavors and your population is only telling you what they most prefer out of that list of flavors. Let's say they all actually prefer lemon. Now, the most preferred out of these flavors might be caramel, but as soon as we add lemon, then the most preferred flavor is actually lemon. But if we try to naively apply our previously inferred preferences to our new list of choices, we might do something strange and just, directly say, oh, the most preferred is caramel. That recommendation is going to be fairly wrong. It might even be worse than just recommending a random flavor from our new list of choices. So we have our factory here, dependent on our list of choices, that provides us a fresh recommender service. And I'm using fresh explicitly here to state that there is no relation of this recommender service to a prior instance of the recommender service that could have been used previously. In a real application, the providers could be all sorts of things, like a HTTP service, in which case it might have persistent state, or you might even want a provider that is instantiated from some serialized state, thus giving you some persistence in your recommendations, even across application instantiations. So for now, we're going to be using fresh only, and this is going to dispatch just straight to that TensorFlow constructor that we had previously. And this is all we really want to do in these factory methods, these really quick dispatches, because we're just providing a convenience here. We still want our users to have access to a specific implementation if they want, without missing any important logic that might have been in this factory here. Before we dig into a TensorFlow implementation for this service, let's consider some alternatives that might be useful on the immediate, both for continuing to validate adding a recommender to our system, but also to test our TensorFlow implementation against some other implementations to make sure that we are really doing better. The two other implementation providers we're going to talk about is a constant provider. This is very easy and quick to write, and it might actually not be a bad choice to always say, for instance, that the first item in the list is the recommended one, and then we can leave it up to whoever's building the list to take their knowledge and put the first one, what they think is going to be the recommended one. And quick to deliver, we can get it out there, deploy it, start validating the idea of having a recommended flavor with something that might actually work quite well. The other one is an imaginary random provider. I'm not going to implement this, but you can imagine what it does, very similar to the constant, where it just picks every single time a random flavor to recommend. Comparison against random is quite useful to verify whether or not our model of a learned recommender or a learned system is better. If it's not better than random, something odd is happening with our hypothesis. We really want anything that is smart to be better than random. I've stopped with implementing the constant one here. And I did save it so it would attempt to compile, just to show off this nice feature where if you have some interface here, I know we can look at it right here, but if we have some interface and we don't have it readily available what we need to implement, well, I'll just try to implement an empty one. And of course, the error will contain, for your convenience. These are some usable stub methods. Quite nice. I'm just going to grab those ones so I don't have to use a mouse. And what we should see is this compiling, and again, we expect it to fail with a not implemented error, which it did. We just do something like that. And update, well, we don't really do anything for update. There's nothing to update. And that would be a constant provider. And in fact, here we're saying, oh, we want a recommender fresh, but we could now say, well, let's get a recommender that always tells us that the first flavor is recommended. And indeed, that's what we see. And just for fun, we'll say like the third flavor is the recommended flavor. Yeah, and it just says more caramel is the recommended. All right. But we're interested in making one that learns what this distribution is that we can then recommend according to that distribution of preferences. And that is the TensorFlow one. This video, however, has gone on quite long. So I'm going to end it here, and next video we're just going to focus on implementing the TensorFlow one. We have all the structure for making this a deployable production recommender, very basic recommender, but it will check all the boxes of what you'd want. The code for this is up on GitHub. You can see the current state as it is at the end of this video if you check it now, as well as the drafts that contain the complete implementation in there. And I'll put that in the description down below. Hopefully I will get back to this soon. Should be pretty easy. I got it all drafted up. Until then, I hope you have a good day.